example, verify the divergence form of the Greens theorem for f equals to, say, 3x plus 4y, and the disk of radius 2 centered at the origin. Okay. This is the Greens theorem. We want to check that this is indeed true for this context. Okay. Let's try to solve this. Now, in order to calculate the left side, you need to, because it's going around the boundary, you have to parameterize the boundary. It doesn't matter if you parameterize it counterclockwise or clockwise. Usually counterclockwise is easier, so let's use counterclockwise. So what's the parameterization of this boundary of disk of radius 2? RT is? Yes? 2 cosine t.
2 sine t.
2 sine t, yes. Okay. With this parameterization, I want to compute this. But wait, there's one more. I need to figure out what this n vector is. Okay? And here's how it works. T is really the angle from the x-axis if you use this parameterization, right? And therefore, at t, what's the normal vector? See, actually, the position vector is proportional to the normal vector. They're pointing in the same direction, right? Yeah. And the only thing that's required of n now is the direction is perpendicular. What's the second condition? It has to be a unit vector. This hat means it's a unit vector, right? So how do you make this a unit vector? Divide by 2, because if you divide by 2, you get a unit vector, right? The length of this vector is 2. Right? So if you divide by 2, you get the unit vector. Right? If you take the norm of this, you can see that the norm is 2, so divide by the norm, you get the unit vector. Okay? So in this context, we know that the outward normal vector nt is really cosine t, comma sine t. All right? Okay, now let's compute. Integral over d, f is 3x, comma 4y, dotted with cosine t, comma sine t, times ds over dt. See, when you compute a line integral, always the trick is divide by dt, multiply by dt. Okay? Divide by dt and multiply by dt. Okay. What is ds dt? It's the derivative of dr dt and norm, right? So let's figure out what to put there. ds dt is dr dt, and take the norm, which is negative 2 sine t, comma 2 cosine t, which is square root of 4 sine squared of t plus 4 cosine squared of t. Sine squared plus cosine squared, that's 1, isn't it? 4 sine squared t plus cosine squared of t. That's just 1, so you get square root of 4, which is 2. I mean, we could have known that without doing all the calculation, right? I know that sine comma cosine should be norm of 1, and it's multiplied by 2, so it should be 2. It doesn't require all this calculation. Just did it so that everybody can understand, but you can just figure out it's 2. All right, so we have it now. Oh, however, we need to change this to x and y into t. What do you do? What do you replace x by? X should be replaced by
2 cosine t.
2 cosine t. See, f should be evaluated over this curve, so you should think of x as this and y as this. Okay? All right, so we have to calculate over the boundary. Over the boundary, it's 3 times 2 cosine t, 4 times 2 sine t, times cosine t, sine t, times 2 dt, and t goes from 0 to 2 pi because it has to go all the way around the circle. And then 6 times 1 times 2, that's 12 cosine squared of t. 4 times 2 times 2, that's 16 sine squared of t. 0 to pi dt. And because of our lack of time, let me just tell you what to do afterwards. You use cosine squared equal to 1 plus cosine 2t over 2. And sine squared is 1 minus cosine 2t over 2. You can simplify and do the integral because we've done these integrals earlier in the class today. Let me skip that. It's going to end up with the total integral. If you do it at the end of the day, you're going to get 6 plus 8 times 2 pi. 6 plus 8 is 14. 14 times 2 is 28 pi. Okay? That's what you're going to get. 28 pi. All right. So, sorry I had to skip that step, but it's not so hard, so you should be able to do it. Now, how would you do the other one? Over the domain B, I have to take the first quantity and differentiate by x. That's what it says, right? The first component has to be differentiated by x. Second component has to be differentiated by y. That's 3 plus 4, which is 7. If you pull a 7 outside, it's 1 dA. But that's the area of the circle. Right? What's the area of this circle? Pi times 2 squared, which is 4 pi. 4 pi times 7, 28 pi. Done? So indeed, you've shown that the two sides are equal.